So this is the third session of kinetic theory of gases. Hope you have covered the first two parts, right? Now, let us proceed. We have covered these topics. First was the assumptions regarding the properties of gas molecules. Then was degrees of freedom. What is a constraint and what not. We have calculated degrees of freedom, law of equipartition of energy, pressure of gas in a closed container, and so far we have done. The next part is kinetic energy and its temperature dependence. Alright? So far we have calculated this. Okay? We have calculated the value of pressure inside the closed container to be mn naught v squared by 3. But we also know there is something called as ideal gas equation, right? So ideal gas molecules are supposed to follow the law PV equals to nRT, where the values are as mentioned. P is the pressure, V is the volume, N is the number of moles, R is the gas constant, T is the temperature, and so on. Now this is another way to write pressure. Not really important as of now, but okay, just note it. Certain differences that I can tell you here is that in case of the first equation, V is the velocity and N naught is the number of particles per unit volume. Okay, total number of particles N by unit volume. Whereas here in PV equals to nRT in the second equation, V is the volume and N is the number of moles. Alright, I hope that's clear. Moving on. Now the first part we can write like this. Okay, the small n naught has been replaced by capital N or total number of molecules by volume, and the second expression can be written like this: PV equals to nRT, nRT by V equals to P. Now both correspond to pressure, so let us equate both of them, right? The first term that goes down is volume, because if you remember, I mentioned that this is the volume, nRT by volume. Volume of the closed container is going to be the same. Assume it is the same closed container that we saw some time ago. There was a cubic box, and inside the cubic box this closed container was the cubic box was the closed container inside which gas molecules were there. Alright, so both the values of pressure were same for the cubic enclosure. So let us equate both the pressures. Equating, we have got this volume cancelled out, and now here we need to relate kinetic energy with temperature. We have a temperature term on the right hand side, but originally there is no kinetic energy term on the left hand side, and we know that kinetic energy is half mv square. So what do? We multiply 1 to this LHS, left hand side term. 2 by 2 is 1, 3 by 3 is 1, 4 by 4 is 1, any number divided by itself is 1. So we get 1 by 3 into 2 by 2 into m into n, that is the total number of molecules, into v squared. We keep 1 by 2 mv squared inside the bracket, take the total number of molecules n out, and we have got a coefficient of 2 by 3. So this left hand side term is equal to the right hand side term, nRT. So we can say half mv square as the kinetic energy, and Na is the, here n is the total number of molecules. Now ये पूरा expression for n number of molecules है. But if we want it to be for 1 mole, then this n is going to be 1, and this n will be 6.023 into 10 to the power 23. That is the value of Na, Avogadro's number, right? Na 6.023 into 10 to the power 23 numbers. So n equals to 1, 1 into 3 by 2 RT equals to kinetic energy multiplied by number of entities in a mole. So kinetic energy equals to 3 by 2 R by Na into T. So kinetic energy equals to 3 by 2 kBT. Note that R equals to kB into Na, right? So kinetic energy equals to 3 by 2 kBT, where kB is the Boltzmann constant. The value is as mentioned here, 1.38 into 10 to the power minus 23 joules per Kelvin. Now you obtained this kinetic energy equals to 3 by 2 kBT for a motion in 3 dimension, motion of a particle in 3 dimension for degree of freedom being 3. So for 1 degree of freedom, how much can we say it is? So Ke per degree of freedom is equals to 1 by 3 into 3 by 2 kBT, that is kBT by 2. Okay, this is the kinetic energy of gas molecules per unit degree of freedom. I hope that's clear. And this is the general formula. If you have been given the degrees of freedom, or if you have been given a system where you can figure out the degrees of freedom, kinetic energy equals to degrees of freedom by 2 into kBT. Okay. You have had a number of cases like say monoatomic. What do you have? Degree of freedom was 3. So kinetic energy is 3 by 2 kBT. Similarly, diatomic, triatomic, linear, triatomic, nonlinear. I want you to calculate these values, or calculate the values of kinetic energy for these three, okay, and put them in the comment section. All right. Now this is as far as kinetic energy topic is concerned. I mean, for all practical purposes relating to your exams. All right. Now, the next part is specific heat capacity. If you remember whatever you have learned in 10th, while going into less details, specific heat capacity is the amount of heat required to raise the temperature of a unit mass by 1 degree Celsius, okay, or say 1 degree Kelvin. That's the better use. So when it is at constant volume, that means specific heat capacity is the amount of heat required to raise the temperature of a unit mass at a constant volume by 1 degree Kelvin. ठीक है. अब keep it in mind always that here we are discussing about a closed container. Now closed container का volume change होना है? No. the volume is not gonna change. So if volume is not going to change, this dV here, change in volume, is gonna be 0. So dQ is the total heat provided or total energy provided, whatever you prefer to call it, and du is the change in internal energy. So we have the total energy provided equals to the change in internal energy. बिकॉज अगर वॉल्यूम चेंज नहीं होगा, एनर्जी जो प्रोवाइड होता है वो दो तरीक़ों में यूज़ हो सकता है, या फिर इंटरनल एनर्जी चेंज होता है और कोई वर्क डन होता है. अगर वॉल्यूम चेंज होता है तो कोई वर्क डन हो सकता है, बट वॉल्यूम चेंज इज़ ज़ीरो हियर. ये कोई पिस्टन अरेंजमेंट नहीं है. दिस इज़ नॉट एन इंजन, दिस इज़ ए क्लोज कंटेनर, सो वॉल्यूम इज़ नॉट सपोज टू चेंज. सो सारा का सारा एनर्जी जो दिया गया है वो इंटरनल एनर्जी को चेंज करने में यूज़ होता है. ठीक है. सो द एनर्जी प्रोवाइडेड इक्वल्स टू चेंज इन इंटरनल एनर्जी. सो एनर्जी तुमने कितना प्रोवाइड किया है, E इक्वल्स टू F/2 kBT, राइट. सो दिस इज फॉर वन मॉलिक्यूल. व्हाट अबाउट फॉर n मोल्स? ना पहले तो ये पता करो एक मॉलिक्यूल के लिए इतना है, तो n नंबर ऑफ मॉलिक्यूल्स के लिए यू कैन हैव व्हाट, n इंटू F/2 kBT. बट अगर n मोल्स दिए जाए, n मोल्स का मतलब क्या होता है? n मोल्स का मतलब कितने मॉलिक्यूल्स, कितने एंटिटीज़, यानी कि n इंटू 6.023 इंटू 10⁻23 एंटिटीज़, उसके बाद kBT. सो चेंज इन एनर्जी dE इक्वल्स टू चेंज इन इंटरनल एनर्जी इक्वल्स टू F/2 n इंटू एवोगाड्रोस नंबर इंटू kBT. एंड पिछले पेज याद करो, कीप दिस इन माइंड, R इक्वल्स टू kB इंटू Na. दैट मीन्स you have got kB into Na here, F/2 nRT. कंटेनर क्लोज्ड है, वॉल्यूम चेंज नहीं होता है, dV इक्वल्स टू 0. टोटल एनर्जी प्रोवाइडेड इज द एनर्जी यूज फॉर चेंज इन इंटरनल एनर्जी, एंड हेंस चेंज इन एनर्जी और चेंज इन इंटरनल एनर्जी तुमको मिल गया F/2 nRT. Now CV, mathematically the easiest way to find in this case is rate of change of internal energy per degree और per Kelvin. यहाँ पे तुमने एक यूनिट वॉल्यूम का जो कैलकुलेशंस करना था कर लिया. अब अभी उसी यूनिट वॉल्यूम का जब 1 डिग्री सेल्सियस या 1 केल्विन के हिसाब से टेम्परेचर चेंज होगा तो you will obtain the value of CV. This is something you can very easily do. You know, d by dt of t to the power 1 is equals to 1 t to the power 1 minus 1. Okay, that is equals to 1. So basically CV equals to F/2 nR. ये क्या है, किसके लिए है, राइट? फॉर दिस 1 मोल, बिकॉज यहाँ पे हमने जो भी कैलकुलेशंस किए हैं ये 1 मोल कंसिडर करके किया गया है. 1 मोल में अगर इनको तुम 1 डाल दो तो तुम्हें 1 मोल का वैल्यू मिल जाएगा. सो हियर यहाँ पे तुमने जो किया है वो सम नंबर ऑफ मोल्स, n इक्वल टू नंबर ऑफ मोल्स, देख रहे हो यहाँ पे n इज़ द नंबर ऑफ मोल्स, n is the Na equals to Avogadro's number. So if number of moles is 1, then CV equals to F/2R. And if you have gone through your book, there is something called as Mayer's formula. Okay, that means Cp minus Cv equals to R. यहाँ से you can deduce that Cp equals to Cv plus R. That is always the case. So Cp equals to CV प्लस R. CV का वैल्यू हमने 1 मोल के लिए क्या ऑब्टेन किया है, F/2R प्लस ये जो R एज इट इज़ आ जाएगा. So F plus 2 by 2 into R, that is the value of Cp, right? Cp is the specific heat capacity at constant pressure. ये P एंड V जो है वो कांस्टेंट टर्म्स को डिनोट करते हैं, ठीक है. Now let us try this. This is something we have covered in the class, but I'll still wish that you people do it here, because CV का फॉर्मूला तुम्हें पता है, F/2R for 1 mole. CP का फॉर्मूला तुम्हें पता है, F plus 2 by 2 into R for 1 mole. ये gamma is a new quantity for you people. This is gamma equals to Cp by Cv, right? We can discuss more about this later, but now your task, say Cv for monoatomic is 3 by 2R, then Cp for the monoatomic system is 4 by 2R, and gamma equals to 5 by 3, or whatever value you can calculate, right? You can also put it in decimals, but I'd rather prefer to keep it in this format. Now again, your task is fill all of these blanks for the diatomic and triatomic cases. All right, and that brings us to the conclusion. Your exams are on. Best of luck, and thank you. That's all that will concern your exams for the topic KTG. Some previous videos have also been tagged. If you haven't covered, that is KTG 1, KTG 2, and this is the final one, KTG 3.